This presentation provides an overview of Chapter 16 in the book titled Simple G, a gridded economic approach to analysis of sustainability of the Earth's land and water resources, edited by Iman Hakiki and Thomas Hurtle, and published by Springer. In this chapter, we'll look at global groundwater sustainability and virtual water trade, which is another application of this global to local to global framework. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover Chapter 16, which is on global groundwater sustainability and virtual water trade. Previous chapters laid the groundwork by providing theoretical foundations, introducing general conditions, specifying mathematical equations, discussing the gridded data and parameters, computer implementation, and validation. This chapter is an application of the Simple G framework at global scale. Groundwater depletion is a global sustainability challenge that calls for urgent action. Agriculture is the primary driver of this excessive pumping, with around 25% of irrigation relying on already stressed groundwater sources. If we continue this trend, we risk losing aquifer storage capacity and encountering saltwater intrusion, which degrades freshwater quality and are irreversible outcomes. Sustainable management of groundwater is critical for communities. One complementary solution is virtual water trade, which allows water-scarce regions to import water-intensive goods from areas with abundant freshwater resources. Due to the high share of groundwater in crop production, there are food security concerns about groundwater sustainability policy. What are the impacts of large-scale groundwater sustainability restrictions? With the Simple G, spatially resolved global agricultural economic model, we can look at the impacts on food production and prices, as well as land use patterns. Considering decisions about land, groundwater, and surface water irrigation, we can design a groundwater sustainability scenario. The sustainability scenario is designed using the water balance model global simulations. We'll also measure the contribution of local, regional, and global adjustments in final changes. In addition, introducing farm worker employment into the model will help us get a more comprehensive picture of the distributional impacts. Here, we investigate the consequences of a global groundwater sustainability scenario. The Simple G results suggest that when groundwater is restricted, there will be a significant initial impact on local production, which causes prices to rise sharply. As a result, farmers have an incentive to adapt their practices to avoid income losses and take advantage of the higher prices. This price increase serves as a motivator for farmers in other regions to expand their production, which ultimately affects trade flows. Despite the initial decline, the market signals will encourage the reallocation of resources towards more sustainable practices and ensure the long-term viability of water resources. Our sensitivity analysis demonstrates that the main findings are robust. This example shows why it's important to consider the economic responses and potential spillover effects of conservation policies, as well as their impact on nearby and distant locations. While the global food security impacts are surprisingly modest, the local impacts on communities and employment can be dramatic. This map shows reductions of up to 50% in irrigated agriculture employment in some locations. If you're interested in learning more about groundwater in a global to local context, please review Chapter 16 in further detail, where you'll learn more about virtual water adaptation mechanisms. Here, you'll find additional readings and references you might be interested in further exploring. On this slide, you'll find the link to the Simple G webpage where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the Simple G book, Chapter 16. We encourage you to explore the other companion videos that accompany the book on the Simple G web page.